Hi guys, and welcome back. Hope you're keeping safe and well wherever you are. I want to show you one cool thing about general solutions for tan. Actually, you don't have to stress about this 360 thing. I was doing it in the previous video so that you get the drill, okay? You get used to it. Now that you are used to it, and I hope you are, I'm going to show you that tan is quite a special case. Tan is special, guys. This is why. In the first quadrant, 0 and 90 tan is positive. In the third quadrant, A180, 270 tan is also positive. But something very intriguing is that the graphs are behaving exactly the same way. Okay? What do I mean? Both going up in exactly the same way. Now you're going to ask me, what about sine and cos? Well, I've got news for you. I'm going to plot it down for you here. I'm going to plot down that graph for you. I'm going to plot down that graph for you. Y is equal to sine x. There it is. But look at this. Although sine is positive in the first and the second quadrant, the behavior is not the same. 1 point between 0 and 90 it is increasing, but between 90 and 180 it is decreasing. So although it might be positive, the behavior is not the same. Okay, so we're really not gonna look into that. That's why the general solution stay as the thing when we write it in case of 360. But with tan, this guy is so special that it is not just positive in the first and the third, but it behaves exactly the same way. Between 90 and 180 and 270, 360, it is not just negative in those quadrants, but the behavior is exactly the same, guys. And guess what? This is exactly the same thing that happens in the Cartesian plane, okay? If you think about it, I'm gonna draw roughly here. And if I'm gonna have that straight line, remember, first quadrant, fourth quadrant. So this angle here is what? 180 has angles on a straight line, folks. So whatever you get, you're going to get exactly the same ratio. In fact, we established that the coordinates here are going to be minus x minus y. Then I'm going to have x and what? Y. So you see, it's always going to be the same thing. So it is exactly the same thing with this relationship here. What you have here, you have a negative x and then a positive y. Okay, here you have a a positive x and a negative y. So the ratio is still negative. So the behavior exactly the same. We can say tan is positive in quadrants that are symmetric and negative in quadrants that are symmetric. So instead of using 360 and having these repetitions, we can actually just use 180. Okay, at 180, we're actually done with the tangent graph. Okay, here, yes, right at this point, we are done because everything else that follows is going to be a repetition of what we have seen already. So let's see, let's try and take this example and find the general solution for what? For tan x is equal to square root of 3. Okay, let's try and find the general solution for that. I'm actually going to switch to my whiteboard now so that we can write clean and nice. This graph doesn't confuse you. So there it is. You have it. Tan x is equal to square root of 3. I'm going to use k dot 180. Guess what? It works perfectly as k dot 360. So it's just that k dot 180 is a shortcut and no repetitions. Yes, that's it. So my reference angle is actually 60 degrees because tan 60 is square root 3. Therefore, my solution x is equal to 60 degrees plus k dot or times 180 degrees. And I must mention that k is an integer. Yes, that's it. Why should I use 360? You may, and I don't really now, when I've done this, guys, yes, I don't need to think about what is the other quadrant where tan is positive, because this solution itself will give me that angle. Let's think about it. If you were to think about that, then you'll say, oh, but tan is also positive in what? The third quadrant. And in the third quadrant, I have 180 plus theta, okay? So you were gonna do this. You are going to do this, right? And then you're like, oh, but this is actually 240 plus k dot 180. And I'm asking you, guy, why are you repeating what you have already written? And you're probably wondering, Mr. G, what do you mean I've already written? I have 60 there. I'm going to tell you, this 240 can be generated from this solution. Yes, if k equals to 1, then you have x equals to 60 plus 180, boom, 240 degrees is there. So believe Mr. G, I've got this sorted for you. You don't need to stress, and you can defend yourself if they make you lose some marks. Show them that, hey, oh, no, I got this. Okay, so yep, guys, that's the story of 10. Very special. I don't have to stress about finding the other solution and all that. And you're asking me, Mr. G, is this the same thing that happens with the negative quadrants? And I'm gonna shout, yes, it is. We wanna test that? Yeah, let's go for it. What if tan was a negative half? Okay, let's tan alpha. So let's get our reference angle quickly. So remember, we're gonna say arctan and say half, not negative half, because we're just looking for the reference angle. And this is 26.6 degrees. Okay, then I'm gonna write my solution and do this plus k dot 180, and k is an integer. Okay, right? And you are asking me, don't you need to consider that tan is negative and all that? And I'm gonna say, yeah, actually you got that right. You got that right, because actually that's gonna be a solution in the first and the third quadrant rather. So my apologies there. I actually have now to say 180 minus 26.6. Yeah, too excited. Then I'm gonna get here 153.4 degrees. Yes. What did I do here? I just did 180 minus theta, because that's where tan is what? Is negative. So this is my solution. That's it. Do I need to do the 361? No, I don't need to do the 361. Why? Because I'm still going to get it. Okay. Do you understand what I'm saying? And okay, let's put it to the test. Suppose you say 360 minus, what is your reference angle? 0.6. So let's do that. 360 minus 26.6. This is 333.4. But I'm telling you, you are repeating unnecessarily, because this solution can be generated here. And you ask me how? Well, let's see what happens if k is equal to what? Let's try 1. Let's see what happens if k equals to 1. So if k equals to 1, I'm going to have 180 plus 153.4. What is that? Oh boy, okay. Guess what? 153, sorry. I love maths, guys. But in particular, I've said this, I love trigonometry. This plus 180, my calculator tells me a story. It is 33.4 degrees. Isn't it that? So what was the need for doing that? You realize when you add 180, as I showed you just now, if you were here, this is the angle that you have, okay? You are adding 180, you're gonna get this angle there. That's this thing, I told you angles on a straight line. This thing here in purple is exactly 180. So you're just going there. You will still get the same ratio, right? Yes, that's the story about tan, and that's how cool it is to work with tan. So with tangent, guys, instead of saying k dot 360, k is an integer, and repeating the same thing and say what is the other quadrant where tan is positive or it is negative, you can just stop right on the first solution that you get. You can stop right there and then, and you would have actually found the complete general solution. Of course, if they say in a specific interval, in the interval 0 to 180 or minus 180 to 180, then you will have to punch in k equals to 1 minus 1, k equals to 2 minus 2, and just see if those values will fall within that interval. Having said that, The next video, I'm actually discussing finding solutions in specific intervals. But this discussion will be done under another critical discussion, which is finding values where an identity is undefined. So stay tuned and keep in touch. Catch you later.